Hello friends, myself R.D. Mahajan presenting my video on Fourier Series Revision Part 3. Find Fourier Series for f of x is equal to square root of 1 minus cos x in the interval 0 less than or equal to x less than or equal to 2 pi. And as this is the limit, we require to find out full range Fourier series. Formula to find full range Fourier series is f of x is equal to a0 by 2 summation of an cos n pi x by L, n changes from 1 to infinity, and summation of bn sin of n pi x by L sin n pi x by L, n changes from 1 to infinity. We call this equation 1. Here limits from c to c plus 2l. Here the value of c is 0. C plus 2l is 2 pi. Substituting value of c as 0, we get 2l equal to 2 pi, means l equals to pi. And then we require to obtain this Fourier coefficient, where a0 is given by, formula is 1 by L integration from c to c plus 2l f of x dx, and therefore it is equals to 1 by pi, value of c is 0, lower limit, upper limit is c plus 2l, and that upper limit is here 2 pi, and the function is root of 1 minus cos x. That root of 1 minus cos x we can write down as square root of 1 minus cos theta is nothing but 2 sin square theta by 2. Therefore, it is 2 sin square x by 2 root 2. Square root of sin square is sin x by 2. And therefore, this function is root of 2 sin of x by 2 and its integration with respect to x. Root 2 constant term we take outside, the integral sign by pi. Integration of sin is minus cos of x by 2 divided by 1 by 2, limit from 0 to 2 pi. Minus sign is cancelled by changing the limit, and therefore we get 2 root 2 by pi. Cos 0 is 1 minus cos of x is 2 pi divided by 2. 2 to get cancel, we get cos of pi. And therefore, it is 2 root 2 divided by pi. Cos pi is minus 1. Minus minus it becomes plus 1. And 1 plus 1 we get 2. And therefore, the value for a0 is 4 square root of 2 divided by pi. If the question is asked for 6 marks, 1 mark for this calculation of a0. Then we require to find out remaining coefficient an and b. Formula to find an is 1 by L integration from c to c plus 2l f of x into cos of n pi x by L and its integration with respect to x. Then substituting the values, L is pi, lower limit is 0, upper limit is 2 pi. Fx is this square root of 1 minus cos x, means root of 2 into sin of x by 2, a new value for that function after converting it, and into cos of n pi x by pi. Pi get cancelled, we get cos of nx. Then taking this root 2 outside, we get root 2 divided by pi integration from 0 to 2 pi. This product we have to convert into sum. For that we have to multiply by 2 and divide by 2. Therefore, multiplying by 2 and dividing by 2, so that no change in the original value. Sine of x by 2 into cos of nx. Therefore, it is equals to root 2 divided by 2 pi integration from 0 to 2 pi. We know the standard result, 2 sin a cos b is sin a plus b plus sin a minus b. As per that, it becomes sine of a is here x by 2 b nx plus sine of a minus b sine of x by 2 minus nx, and then its integration with respect to x. Integrating individually with respect to x, we get root 2 divided by 2 pi, as it is no change. Integration of sine is minus cos of, we can take x common, therefore it is 1 by 2 plus n times x divided by, the coefficient of this term is 1 by 2 plus n, then minus integration of this sine is again cos minus cos of 1 by 2 minus n times x whole divided by 1 by 2 minus n, and limits from 0 to 2 pi. We can take minus sign common and then cancelling that minus sign by changing the an is equals to root 2 divided by 2 times pi. Upper limit is 0 and lower limit becomes 2 pi. We have cos 0. Cos 0 is 1 divided by 1 by 2 plus n. Again cos 0, 1 upon 1 by 2 minus n. And then for the lower limit it becomes minus, substitute value of x as 2 pi, multiply it inside, we get 2 get cancelled, cos of pi plus 2n pi divided by 1 by 2 plus n, and plus again x as 2 pi, 2 to get cancelled, we get cos of pi minus 2n pi whole divided by 1 by 2 minus n. Cos of 2n pi plus theta as cos theta, and cos 2n pi minus theta is also cos theta, and therefore applying that result here, we get, therefore an is equals to root 2 divided by 2 pi, cross multiplying this, we get 1 by 2 plus n plus 1 by 2 minus n, and whole divided by a plus b, a minus b, that product is a square means 1 by 2 square as 1 by 4, and minus b square n square. Minus cos 2n pi plus theta is cos theta means it is cos pi divided by 1 by 2 plus n, and plus cos pi minus 2n pi, we can write down as cos 2n pi minus minus pi as cos theta, means it is cos of pi divided by 1 by 2 minus n. From these two terms I can take cos pi common, and therefore it is root 2 divided by 2 pi. N minus n get cancelled. 1 by 2 plus 1 by 2 we get 1 divided by 1 by 4 minus n square minus cos pi. Value of cos pi is minus 1 common into, again cross multiply, we get 1 by 2 minus n and plus 1 by 2 plus n whole divided by a plus b, a minus b. That product is a square minus b square. A square means 1 by 2 square, 1 by 4, and minus b square n square. And therefore we get root 2 divided by 2 pi. Again minus n plus n get cancelled. 1 by 2 plus 1 by 2 we get 1. Minus minus it becomes plus. Therefore it is 1 plus 1. We get 2 divided by same denominator. Therefore adding numerator term or finding LCM, we get 1 by 4 minus n square. And therefore cross multiplying it by 4, we get this 2 to get cancelled. We have root 2 divided by pi into 1 upon 1 minus 4n square divided by 4. That 4 goes to numerator. Therefore here it is 4. Therefore the value of an is 4 square root of 2 divided by pi into 1 minus 4n square. If you perform this correctly, all steps are correct, then you will get 2 marks always for calculation of an. Then in last step we have to then bn formula is 1 by L integration from c to c plus 2L f of x multiplied by sine of n pi x divided by L and its integration with respect to x. Substituting the values, we get 1 by pi, c lower limit is 0, c plus 12 upper limit is 2 pi, fx is square root of 2 into sine of x by 2 multiplied by sine of n pi x by pi. Pi get cancelled, we get sine of nx only. Here also we have a product of two trigonometric terms. Therefore to convert that product into sum, we multiply it by 2 and divide by 2. Means applying the factorization formula, we get root 2 divided by 2 pi integration from 0 to 2 pi 2 sin a sin b. That result is cos of a minus b x by 2 minus nx minus cos of a plus b x by 2 plus nx, and this we have to integrate with respect to x. Root 2 divided by 2 pi, no change. Integration of cos sine of 1 by 2 minus n times x divided by 1 by 2 minus n minus integration of this cos, again sine of 1 by 2 plus n times x divided by 1 by 2 plus n and limits from 0 to 2 pi. Substituting the upper and lower limit, we get root 2 by 2 pi. For upper limit, if we put x as 2 pi, we get sine of, multiplying it inside, we get 2 get cancelled, we get sine pi minus 2n pi whole divided by 1 by 2 minus n and minus sine of, again, pi plus 2n pi whole divided by 1 by 2 plus n, then minus, for the lower limit, when x is 0, sine 0 is 0, this sine 0 is 0, therefore 0 minus 0, we get 0. Then we have the standard result, sine pi minus theta and sine pi plus theta. Sine pi plus theta is minus sine theta and sine pi minus theta is plus sine theta. And therefore, using this standard result from trigonometry, sine pi minus theta is sine of theta, and therefore that becomes sine of theta. Theta is here 2n pi divided by 1 by 2 minus n, and sine pi plus theta is minus sine theta, therefore minus and again minus sine of theta. Theta is 2n pi. And whole divided by 1 by 2 plus n. Outer term as it is, that is root 2 divided by 2 pi. But the value of sine 2n pi is 0. This is also 0. 0 minus 0, we get that value as 0. That is value for Bn. And for this calculation, you will get 2 marks. 2 marks for the calculation of Bn. And then, after getting all these values, we put here in equation 1. Function is root of 1 minus cos x 4 root 2 divided by pi and divided by 2 summation from n equal to 1 to n. An is 4 square root of 2 divided by pi into 1 minus 4n square into cos of nx. Bn is 0. This is the required. Or from this two term, we take 4 root 2 divided by pi common. Here remains 1 by 2 plus summation from n equals to 1 to infinity. The remaining terms are here 1 upon 1 minus 4n square into cos of nx This is the required Fourier series. for that given function, square root of 1 minus cos x. If you like my video, one more I will discuss in my next part, that is part 4. If you like my video, please share it as well as subscribe to my channel, and to receive the notification for my such type of new videos, you have to press the bell icon. Thank you. Thanks for watching.